Welcome back, students. Today we're going to continue our work in Chapter 6, Additional Topics in Trigonometry. We are still doing Section 6.2, the law of cosines. Yesterday we looked at using the law of cosines to solve triangles, and today we're just going to do this objective here. We're going to look at applied problems, that is, word problems using the law of cosines. So just a reminder, here's the law of cosines. We had three different versions of it. They're really all the same equation. It depends on which side length you either know or want to find, or what angle you know or want to find. So let's take a look at a word problem here. So two airplanes leave an airport at the same time on different runways. One flies on a bearing of north 66 degrees west. Now, to interpret that, that means that it is flying 66 degrees west of north is what that means. And it's going 325 miles per hour. The other airplane is on a bearing of south 26 degrees west, and that means that it is flying 26 degrees west of south. That's how you interpret those at 300 miles per hour. How far apart will the airplanes be after 2 hours? So for these problems, you should always draw a diagram. Draw what you know, and then label the lengths or angles you know. You should, at some point, see a triangle emerge in which you need to find one or more missing parts of that triangle to answer the question. So I'm going to draw a picture of this, and I'm going to start by giving myself a little compass here, north, east, south, west. And then I'm going to draw the path that these two planes are flying on. So this first plane is flying north 66 degrees west. That's 66 degrees west of north. Here's what that means. It leaves this point right here. North would be in this direction. It's traveling 66 degrees west of north. So from north towards west, 66 degrees. So this is the path that it's flying on, right there. So this is at a path of north 66 degrees west. That's the first plane. The second plane is on a bearing of south 26 degrees west. So here's south. It's 26 degrees west of south. So from south towards west, that angle right there is going to be 26 degrees. So there's where my second plane is flying. And actually, let's get some planes in here. So there's that plane right there. There's that plane right there. There we go. So that's where the planes are. How far apart will the airplanes be after 2 hours? So this right here, the distance from this plane to this plane, that's the distance I'm trying to find. And you can see, hey, look, I got a triangle. And I want to find this side length. And you can use whatever letter you want. If you want to stick with, these three letters, you can, or use whatever. I'm going to use C for Cody because, there you go. That's side length C that I'm trying to find. Now, in this triangle, I can actually label some distances as well because I know how fast they're going. This one's going 325 miles per hour, but notice the question after 2 hours, so I need to double that because, 325 miles each hour times 2 is 650 miles is how far that plane has traveled. The other one's going 300 miles per hour for 2 hours, so this is going to be 600 miles there that it's traveled. So you can see I have a triangle here, and I know 2 of the sides, but I don't know any of the angles. So the next thing I'm going to do is I'm going to try to figure out one of the angles. And I'm going to use these 2 pieces of information to figure out how big this angle is right here. And this is why the diagram is so important. Because you have to just kind of problem solve and think about, okay, how can I figure out how big this angle is? And there's a few ways to do it. The easiest approach, I think, is to recognize that from here to here is 180 degrees. And if you then subtract off this angle and this angle from that 180, you'll be left with this green angle there. So to find angle C, I can do 180 minus that 66 degrees and then minus that 26 degrees to get that angle C is 88 degrees. And now you can see I have a triangle in which I know two sides and the included angle. And you can see that that is one of the types of triangles that we need to use the law of cosines to solve. So if I want to find this missing side length, I set up the law of cosines, and I'm going to use the version that solves for side length C. Now, I could call the other sides A and B, or whatever letters you want, but basically the idea is the side length I want to find goes over here, the other two side lengths go here and here, minus 2 times, again, the other two side lengths go there and there, times the cosine of the angle that's opposite that side length that I'm trying to find. So I plug in the numbers. Well, I also take the square root to solve for C, and I plug in the values for side length A and B, side length A and B. So it's the square root of, and I can type that in all into my calculator at once. I'm going to round to 1 decimal place, and I get 869.1 miles. This step right here, finding the angle, is going to be a little different for every problem depending on what quadrants your objects are in, and it's kind of like a little bit of problem solving of just like look at your diagram and you have to figure out how to find the angle you want based on everything you know. So let's take a look at another example like that, and and you'll see how this drawing is going to be a little different. So two ships leave a harbor at the same time. One ship travels due north at 9 miles per hour. The other ship travels on a bearing of south 80 degrees east at 12 miles per hour. So again, this right here means 80 degrees east of south. So that means from south you go 80 degrees towards east. So I'm going to draw that diagram. I'm going to start with a compass. So one of the boats just goes due north. So from where they leave, from that harbor, this boat, oops, I can draw lines. This boat right here goes due north. So there's my first boat. So let's throw a boat in there. Yay, there it is. There's my first boat. And then the other boat is going to do 80 degrees east of south. That means from south, go 80 degrees towards east. So that's 80 degrees towards east. So it's going to go like that. And there's my other boat right there. So now, how far are they going to be apart are they going to be after 3 hours? So again, I'm trying to find the distance between these two boats. And this time I'll call that distance, how about A? Then I'm going to label the distances that I know. 9 miles per hour for 3 hours is 27 miles. 12 miles per hour for 3 hours is 36 miles. Now you can see I've got a nice triangle here. I know 2 of the sides, but I don't know any of the angles. So what I'm going to do is I'm going to try to find this angle. And now there's kind of, I don't know, I see 2 different ways to find this angle. One is you can think about this just like we did last time, as that's 180 from there to there, and all you need to do is subtract off that 80 degrees. Another way to think about this is from north to east right here is 90 degrees, and this little chunk right here is going to be, well, if you look at this, from east to south is 90 degrees, and you can subtract off that 80 to get that that's 10 degrees, and then you could just piece together a 90 plus a 10 to get a 100 degree angle there for the angle opposite side length A. So there are a few different ways you can piece together angles depending on how you see the problem. But basically the key is that angle in the triangle that we're going to be using is this green angle here, and that's a 100 degree angle. Then, use the law of cosines, and I'm going to be solving for side length A, so I'm going to use this version. I plug in the numbers I know and do the square root. Use your calculator, and I get about 48.6 miles as the distance between the two boats. Next, I'd like to help you with one of your homework questions. I think it's the last one, was about is going to be about a baseball diamond, and I just want to make sure you understand what it's saying. It's saying that there's a square here made right there, and you can see it's rotated to look like a diamond, and then it tells you that the distance from this point to this point on this straight line connecting home and second, they tell you this distance from the pitching rubber to home plate right here. And you're supposed to find, I think, this distance here. You should read it carefully, though. One key I want to give is that this pitching rubber is not exactly halfway in between those. I know from the diagrams or how you picture a baseball diamond, you might think it is halfway in between, but it's not halfway in between, which means that this angle right here is actually not a 90-degree angle. Okay, so you can't use the Pythagorean theorem or anything like that. You got to use the law of cosines or law of sines depending on the situation. So we actually don't know this angle here. However, we do know the sides of the square. They tell us that, so we know that side length there. And then one other tip I'll give is that we do, however, know this angle down here, because that angle right there is a part of a square. So that angle right there is a 90-degree angle, and I will tell you that this does bisect that angle, which means this angle and this angle are going to be congruent. It might be helpful to draw a diagram in which this is obviously not halfway in between. What I mean by that is, I'm going to draw a square, and then instead of putting the pitcher rubber there, I'm going to put it right there to make it very clear, okay, it's not halfway in between home plate and second. So I'm given this distance on this line, which means these two parts are each half of this right angle there. Okay, and then I'm trying to find that length. You know this length, you know this length. Hey, look, side angle side. So that's what I'd recommend for question number 6. If you have other questions, please reach out via email.